Lesson 16 activity. An exponential growth function is always increasing. An exponential growth function is always concave up. So what does that say about the first and second derivatives of an exponential growth function? So it would say that the first derivative, I guess we were calling it q on the last page, so q prime would be a positive number because the function is always increasing. And because it's always concave up, it would say that q double prime is always a positive number. So positive first and second derivatives are how you get some function to be increasing and concave up. And this is all the time. Q prime has to be bigger than 0 all the time, and q double prime has to be positive all the time. Okay, part A here, number 2. Population of ladybugs is originally 150. That's our starting number. And then the population triples every month. Okay, so if you're going to triple every month, that means you are multiplying the population by 3 repeatedly. 3 to the t is our answer, where t is the number of months. Part B says we start with 32 grams. And it says it gets cut in half every 5,730 years. So if you're going to cut in half repeatedly, that's the same as multiplying by half. Now, I don't want it to get cut in half every year. So if I put a t up here, that would cut it in half repeatedly every year. But I only want it to cut in half every 5,730 years. So if you plug in 5,730 for t, then this fraction would be 1. And that would say, yeah, cut in half one time. Let's suppose that you plugged in double 5,730 years, so whatever that is, 11,460. If you put that right there, then this exponent is 2. And if you are waiting 11,460 years, then you are cutting in half twice, which is exactly what 1/2 squared would do. So no fancy formulas there, just thinking our way to the answer. Okay, part A, looking to find an exponential function that goes through these 2 points. So P of t, so we're going to go off of this blue highlighted equation. That's our basic starting equation. So this point right here, I can plug in P of t, that's the left-hand side, that's 5, equals P sub 0, I don't know, A, I don't know, but t at this particular point is 0. And I can do the same thing with the 1 and the 115. Sorry, the 1 and the 15. 15 is equal to P0 times A to the first. And this first equation is really nice because A to the 0 is 1 for any number A. And so 5 must be the value of P sub 0. And so that means that I can take that and plug it into this equation now. 15 equals 5 times A to the first. So 3 equals A to the first. And let's just write our final answer in the blue highlighted form at the top. 5 times 3 to the t. That function hits the 2 points given right here. Okay, but I was particularly nice giving you a 0 here because that meant that this a to the 0 just vanished. Didn't have to do any work on that one. So I'm going to be less nice on this one. So first point tells me that 10 is equal to P sub 0 times a to the 2. And then the other equation, other point I should say, is that 30 is equal to P sub 0 times a to the 5th. Okay, so this one is not as nice because we don't just have a to the 0 where it just vanished. So we actually have 2 equations with 2 unknowns, and we're going to use the substitution method here. I'm going to solve one equation for one letter and substitute into the other equation. So I'm going to solve this equation for P sub 0. So let's divide both sides by a squared. And then we're going to substitute that into the other equation. So 30 equals, instead of P sub 0, we put 10 over a squared. And then the a to the 5th is still there. Okay. And now some of these a's cancel, that's nice. The point of this is that this last equation has only one variable in it instead of 2. So we get 30 equals 10a to the 3rd. Trying to solve for a here. And the cube root is going to get us there. So cube root of 3, that's the value of a. It says we can round to the nearest thousandth, so we'll do that. Cube root of 3 on our whoopsies, cube root of 3 on our calculator. Cube root, the easiest way to do that is to do 3 to the 1/3. 3 to the 1/3. But if you don't want to do that, you can say, okay, 3 for cube root, and then I think it's inside of math. Right here, number 5. So that 3 that I've typed is the cube root part, and then this 3 is the thing inside the radical. And it happens that cube root, I guess, is used so often that they actually, I forgot they had its own button here, number 4. And that's the cube root automatically. All right, however we slice it, 1.442. Okay, and then we're going to go back up to this equation, which has a p sub 0 equals in it. And that will allow us to solve for p sub 0, 1.442. That was supposed to be squared. So back to the calculator, 10 divided by second answer squared, 4.807. Okay, so we'll just write our final answer here. P of t equals, approximate equals, 4.807 times 1.442 to the t. And that exponential function will pass through the 2 points. Well, actually probably isn't going to pass through either of them, but it'll be darn close to those 2 points. If we hadn't rounded, it would hit them perfectly. Okay, next question has to do with the growth rate. So here's what I know. I know that this thing in the parentheses is 1 plus r, where r is the growth rate. And so for all 3 of these, we're doing exactly the same thing. We're just going to solve 1 plus r equals the thing in the parentheses. So in this case, r, by subtracting 1, is 0.04. It says write it as a percent, so 4%. That's the growth rate there. Here, 1 plus r is 1.276, so that means that r is 0.276, or 27.6%. And then finally over here, 1 plus r equals 0.92, subtract the 1, and I get r is negative 0.08, or negative 8%. So calling it a growth rate is kind of a misnomer, but this one is an exponential decay function. We are losing 8%. Every time period. Okay, number 5 says write that equation in the form p sub 0 a to the t. So we did this thing earlier, but in the opposite direction. We were given with that air freshener, we had a 0.88 to the t, and we wrote it as an e to the kt. So this direction is actually easier, but just like before, the p0 has to be 4. So I know that the other parts have to equal each other. And just like before, we're going to raise both sides to the 1 over t in order to get these t's to cancel. And so on the left-hand side, I get e to the 0.05, and on the right-hand side, it's simply a, and this is our answer. There's no logs that we're bringing into this problem. We're just typing e to the 0.05 on the calculator. Okay, so about 1.05127. So then if we're writing our final answer, it was P of t equals, the P0 we said was just 4, and then A turns out to be this 1.05127 to the t. So we should be able to go both directions. Given the E version, I want you to write it as a generic A base, and if you're given a generic A base, I want you to find the corresponding E to a power. Okay, here, the function e to the x is graphed below left. We're going to draw tangent lines at the 4 dots. So you should use a straight edge. I guess I'll use a straight edge too. Okay, so I drew my 4 tangent lines, and now in part B, I think we're going to estimate slopes. So we're literally just counting boxes. So for the black tangent line, looking for points that are nice. For example, that one looks like it's on the background grid, and maybe this one over here. So that looks like the slope is up 1 over 4. So maybe the slope here is roughly a quarter. And then going to the green one sure looks like it's up 1 over 1, up 1 over 1. So that would make the green slope 1 over 1. And then the blue one, looking for nice points on the blue. What do we have here? So maybe this one right here. And then it's kind of hard. I don't really see another nice point. I'm going to pretend my blue line extends up and hits that point. It's probably not perfect, but counting boxes there. Looks like that one is an up 5 over 2. So maybe something like 2.5. Okay, and then finally the red one is quite steep. I'm going to have a hard time estimating the slope of the red one. You might too. And maybe if I extended it like all the way through the grid, but I'm just gonna make something up. 8. That one's a steep one. Okay, and then we're supposed to plot these 4 points of the derivative on the right-hand graph. And remember, points on the derivative are of the form x comma slope. So I'm just going to write down some derivative points here. When x was -1, we found that the slope was roughly a quarter. When x was 0, that was on the y-axis, we thought the slope was maybe 1. And then when x was 1, I estimated the slope was, what did we get, 2.5? And then when x was 2, I just made a blind guess for that really steep line and called it 8. Okay, and so we're going to plot these 4 points over here on this graph of the derivative. So -1 1/4, and then 0, 1, and then 1, 2.5, maybe here, and then 2, 8 there. And then we're going to, what are we going to do? Sketch the graph of the derivative. So we've got only 4 points, but we can maybe make a guess that it's going to grow really, really quickly here, faster, 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 slower, 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 something like that. And then part E said guess a formula for the derivative of f of x equals e to the x. So I happen to know this one because I've taken this class before. So I'm not going to answer that one here, but maybe you can make a guess as to a formula for that particular curve.